In this section, we want to look at finding the solutions to systems of linear equations. Before we get into those processes, though, we want to talk about what the solution to an equation looks like, and then what the solution to a system of equations looks like. To start off, we'll consider the equation y equals negative 2x plus 7, and ask the question, is the xy coordinate pair 0, 0 a solution to this equation? To check, we'll take that y value, not our x value, we'll take our y value and substitute it in for every instance of y in our equation, and we'll take our x value and substitute that in for every instance of the x variable in our equation, which will give us 0 is equal to negative 2 times 0 plus 7, which will simplify down to 0 is equal to 7, which is clearly not true. So no, 0, 0 is not a solution, because when we plug in that xy pair, it doesn't make the original equation true. Now we'll test the same thing, but with the coordinate pair negative 1, 9. We'll say that 9 is equal to negative 2 times our x value, which is negative 1, plus 7, which will give us 9 is equal to 2 plus 7, or 9, which checks out. Since we do get a true statement in the end, we would say that yes, this coordinate pair is a solution to that equation. And we can generalize that idea by saying that an xy coordinate pair is a solution to a two-variable equation. So in this case, we have the variables x and y, if those two variables make the equation true. Now we want to take that idea and see how it applies to a system of linear equations. Now we have a pair of equations. We want to find any xy values that make both equations true. So the first question is, if negative 1, 9 is a solution. We already know that it is for the first equation, because we just checked that in the previous question that we looked at. Now what we need to do is see if negative 1, 9 is a solution to the second equation. That means we'll have 9 is equal to negative 3 times our x value of negative 1 plus 5, which will give us 9 is equal to 5 plus 3, or 8, which is clearly not true. So no, negative 1, 9 is not a solution to both of these equations, because it fails the second equation. Now we'll consider negative 2, 11. We need to test both points, meaning we'll have 11 is equal to negative 2 times negative 2 plus 7, which will give us 11 is equal to 4 plus 7, or 11, which checks out. So negative 2, 11 is a solution to the first equation. And then we'll try that pair in the second equation, which will give us 11 is equal to negative 3 times negative 2 plus 5, or 11 is equal to 6 plus 5, which equals 11, which checks out. So this coordinate pair negative 2, 11 is a solution to the second equation, meaning the coordinate pair negative 2, 11 is a solution to that system of equations. And we can generalize that by saying that an xy coordinate pair is a solution to a system of linear equations if the two values make the entire system true. That is, every equation that's in the system, we'll be looking at systems of two equations. The xy pair that we're considering needs to make both equations true to be a solution.